Well, good day, everyone, and thanks for attending this webinar. My name is Joseph Chang. I'm a software developer at SensorUp, and today I'm going to be talking about citizen sensing with the SensorThings API. Specifically, we'll talk about the Arctic Citizen Sensors project, which SensorUp has done in collaboration with GeoConnections in Canada. We'll explore how citizen sensing concepts map elegantly to SensorThings entities, and we'll show you step by step how to create the SensorThings entities needed to support your very own citizen sensing platform. But before we jump into the nitty-gritty, we thought we'd give a brief introduction to SensorThings itself. Now, we figure that most of you already have an idea of what SensorThings is, so we prepared a highly technical diagram for you to analyze. Indeed, this is very technical. As you can see, you send sensor data to SensorThings, and happiness, joy, and sunny days are the result. But seriously, SensorThings is an open geospatial consortium standard that aims to connect Internet of Things, devices, and data. It is an open specification, it is freely available, and anyone can implement it. The API itself has been developed with modern, lightweight techniques in mind, and it makes use of simple old HTTP and JSON, while also having support for things like MQTT, which is a lightweight messaging protocol. Now, the other big component of this webinar is citizen sensing. Citizen sensing is the idea that sensors and devices have come down in price such that ordinary citizens can own and operate their very own sensors. They can then connect these sensors to a community platform to share environmental data or anything else that a sensor can observe. One of the key motivators of citizen sensing is the idea that participation leads to engagement and empowerment. When people are active players in an initiative, they feel connected to the process and are more invested in the community as a result. Plus, really the idea of everyone having sensors and broadcasting and viewing all that data is really just kind of cool. But you know what would be cooler than talking about a platform? Building a platform. Can we build a simple citizen sensing platform with SensorThings? The answer is, of course. This would be a silly webinar if the answer was no. In fact, we don't want to show you citizen sensing. We want you to behold citizen SensorThings. Okay, fine, maybe that phrase will never catch on. But here's something that we hope will have an impact. Arctic Citizen Sensors, a project we have been doing in association with GeoConnections, which is itself an initiative led by Natural Resources Canada. One of the goals of this project is to create a platform that enables ordinary citizens in Canada's north to acquire and set up low-cost sensors which can connect to an interoperable IoT system. The sensors will monitor a variety of environmental properties and produce data that can be viewed and visualized by the participants and the general public. The actual device we've been using for this project is a Linkit 1 with a number of connectable sensors for observing temperature, pressure, dust, and light. So what are we going to show you today? We are going to build a simplified version of the Arctic Citizen Sensors platform. But unfortunately, we can't show you everything there is to do in such a short time frame. Instead, we're going to focus on creating and linking the SensorThings entities needed to create a citizen sensing platform. There are important things that we won't be able to cover in this session, such as querying, user interface implementation, and device software. But such is life. Hey, if you keep watching future webinars, we may be able to cover these topics later. Now, before we can create the SensorThings entities relevant to a citizen sensing platform, we should take a look at the entities and relationships that exist in the SensorThings API. Take a good look at this diagram. Memorize the whole thing. There will be a test at the end of this webinar. But seriously, I think a better approach than examining UML diagrams might be to look at how SensorThings entities map to parts of the user interface itself. We can see near the middle that we have our thing, the link at 1. We have our location, shown on the map near the tip of Ellesmere Island. We have our observed property, which in this case is the levels of dust. We also have our sensor, which makes the actual readings of our observed property. It's not in the UI per se, but it's very much related to the observed property. We have our data stream, which joins our thing, observed property, and sensor together, and acts as a group for sequences of observations. And finally, we have our observations. Each point on the chart is an individual observation in its own right. To support our citizen sensing platform, we will have to create the following SensorThings entities: things, locations, observed properties, sensors, data streams, and observations. So, to begin with, we're going to show you how to create a thing. In this case, a link at 1. And here is our link at 1. Its complexion is green with charming yellow highlights, and it is well connected when it wants to be. And to create it is very simple. We just send a post request containing a JSON object to the thing's endpoint, provide the description, and voila, we have created our thing. Note that it tells you the IoT.id of the created entity, which is important if you later want to edit it or to link it to other entities. Now, we can take a look at our user interface and see that we have completed one piece of the puzzle. But there's still much more to do. Next step is to create a location so that we can mark it on a map as shown. We will choose to place our link at 1 in Alert, Nunavut, Canada, which is apparently the northernmost permanently inhabited place in the world. You can file that one away for the next time you're competing on trivia night. To create a location, we'll post JSON to the location endpoint, and it will contain a description and the latitude and longitude of its position. Also note that we are referencing the thing that we created in the previous step. This indicates that the link at 1 is located here in Alert. And again, here is our response. Now you can see that our user interface has what we need to support our map with a dot over our location. Now you may have noticed that some of these slides make reference to feature of interest in connection with the location. Now we won't discuss the feature of interest much in this webinar, but it can be used to specify that an observation applies to a different place than where the thing is located. If a feature of interest is not manually created, SensorThings will create one in the same place as the location. Hence, you don't have to do anything. It's a great deal. You get 2 for the price of 1. Now we're going to create an observed property, which represents the property that a sensor is observing. It can be anything like temperature, pressure, or light, but in this example, we are going to create the observed property of dust. To create this observed property, we'll post JSON to the observed property endpoint. You may note that for the definition, we linked to the DBpedia entry for dust, and the description is an excerpt from that same page. And again, here is our response. Now you can see that bit by bit, our user interface is taking shape. Now we can see our thing, the linked one. We can see its location in alert. And we can see the observed property, which is dust. Next, we're going to create a sensor, which is the entity that actually observes the relevant property. And here is the sensor itself. It's called a Grove dust sensor, and it's attached to the linked one. And here is the request. In this case, we're inputting dust as the description, and we're making a reference to the wiki page for the Grove dust sensor. And here is our response. Now, you may notice that our evolving user interface is not on this slide, and that's because the sensor is not shown directly on the user interface. But just in case you were wondering, yes, you still have to create it, and that's a good thing because it provides context within the data model, and it gives you future querying options should they become important in the future. And anyway, it's good practice, like eating your vegetables, so do it. Now we're going to put all together by creating a data stream, which is somewhat abstractly represented in the chart. You'll note that the request references the thing ID for the linked one that we created earlier, the observed property ID for dust, and the sensor ID of the Grove dust sensor. The unit of measurement is also specified, which indicates that dust is being measured in pieces per 0.01 cubic feet. And here is our response. And now you can see that our user interface has one more big component. We've now set up a place for our observations to go. And speaking of observations, here we are. We're going to create one right away. Every point on the chart is an observation, and the picture on screen points out a single observation for your viewing pleasure. Here's our request. Note that the data stream ID is present in the path of the post request, and that the JSON body contains the result, which in this case represents 334.6 pieces of dust per 0.01 cubic feet. And here is our response. You might notice that this observation has been assigned a phenomenon time, which is equal to the time when the server received the observation. If the phenomenon actually occurred at a different time, this property can instead be specified by the client in the request itself. And now we finally have the finished picture. We've created a thing, location, observed property, sensor, data stream, and observation. So everything is in its place. Now the only thing left to do is churn out those observations. After all, in a typical system, observations will be the most numerous entity by far. Well, it's been quite a journey. Believe it or not, we've shown you how to create all the entities needed to support an application like the one we're showing on screen right now. We've created our thing, the linked one. We have our location, which is alert in Nunavut. We have our observed property of dust, our sensor, which is the Grove dust sensor. We have our data stream linking everything together, and we have an observation for our chart. Of course, we didn't get a chance to show you everything. For example, SensorThings isn't just static. In fact, it also has the ability to support a real-time citizen sensing platform through its MQTT extension. But that's a topic for another day. I'd like to thank you all for your time and attention, and I hope that this webinar has been useful and helpful for you.